Alright, now let's look at that. Degree 1 divided by general quadratic expression. Now at this point, instead of general expression like ax squared plus bx plus c, I will look at x squared plus bx plus c. Because it's very easy to get rid of that coefficient a. You just factor it and pull it out of the integral. Right, so it will reduce the number of parameters to play with here. So I will look at this case only. And what about this case? Well, there are two basic cases about quadratic expression. It either factors into a product of two linear, or it doesn't. Right? So let's start with the case when x squared plus bx plus c does not factor. And by the way, what does it mean that it doesn't factor? Well, can you say a condition on b and c, on those numbers, that tells you exactly that this expression doesn't factor? Well, it's something about that square root formula, right? Well, about the quadratic root.
So there's no work there's an a, like a of x squared bx plus c, and so there's still
two things that add up to b don't multiply to produce c.
Something about that number, right? So whether you have roots or not is decided by that number. So doesn't factor means that number is negative. That's exactly what it means. Alright, so then in this case what you do is complete square. Right, so let's complete the square. X squared plus bx plus c is what? A complete square will be x plus b over 2. And then you add c, subtract square of b over 2. And then I will bring that to common denominator. And I will have 4c minus b squared as a numerator. And there is something I know about that number. This number is positive. It's negative of that number, and therefore it's positive. And what I do now is I factor that number, 4c minus b squared over 4. And the remaining part is going to be the reciprocal of that number multiplied by my square plus 1.
You're not supposed to change the x minus b over 2 or...
When I factor this?
No, like you went from x plus b over 2 to x minus b.
Oh. My mistake. Thank you. So what I have here is I transformed the denominator into this form, and of course that constant, that number, can be factored out of the integral. It's irrelevant for integration. And what I have in the integrand, in the denominator, is this sum 1 plus a square. And that's exactly the second case. If I make a substitution, u squared equals that. And we just did it, right, previously, for a different scenario. You put u squared equals that, and then you solve for u. U is square root of this guy. Well, 4 divided by 4c minus b squared times x plus b over 2. So this is what u is. It's a linear substitution. You can always do it. And what it does, it makes the denominator an integral of 1 over u squared plus 1. Well, of course, some coefficients are sitting outside. And then that is simply tan inverse of u. Plus constant. So that's all you have to do in case the denominator doesn't factor. Complete the square, make this 1 plus u squared, and apply tan inverse.